All right, section 1.7 is all about inequalities, okay? So we need to discuss interval notation, okay? So we are going to use parentheses on the number if the inequality contains a less than or greater than sign. So it's strict, okay? I call these strict. It's strictly less than or strictly greater than. It cannot be equal to. That's when we use parentheses. We're going to use brackets whenever the inequality does contain that equal sign, right? So it's can be less than or equal to or greater than or equal to, all right? So brackets are more inclusive, right? They include the number that we're talking about, and the parentheses don't, all right? We're always going to write from left to right, which seems to make sense because we read from left to right, okay, right? That's how we read words, is from left to right. But sometimes with these, it's going to be a little more difficult for us to write from left to right. But that's the rule. We're always going to write from left to right, okay? Another rule is that we're always going to use parentheses on negative infinity and positive infinity, okay? So parentheses on strict, parentheses on negative infinity and positive infinity, brackets on equal to's, all right? So this first example, okay, we have x is less than 3. Okay, so first of all, if you don't know how to read these, that's an issue, right? This is the less than symbol. X is less than 3. So if I were to tell you to put this on a number line, you would go to 3, right? And you need to know which way to go. X is less than 3 says that x can be all of the numbers less than 3. Okay, so it's talking about all of these numbers. Let me make my pen a little skinnier. Okay, so it's talking about all these numbers, right? All of the numbers that are less than 3, right? So we would put a parenthesis right here because we do not have an equal to sign on our inequality. Okay, so we still need to put this in interval notation. All we did here was put it on a number line. So I know that you know this, but let's label our left and our right. Okay, left to right. And I do that because this is the way that we're going to read this. We're going to read it from the left to the right. Okay, well, I like to say, where's this starting and where is it going? Okay, this is starting. Of course, this didn't stop right here, right? It kept on going forever and ever and ever, right? So it's starting from negative infinity and it's going all the way to 3. And it's getting really, really close to 3, but it's not touching 3, right? Because 3 is not included in our answer. We want numbers that are strictly less than 3. Okay, so we're going to put a parenthesis on 3. And of course, we're going to put one on negative infinity because that's our rule. Okay, so that is what x is less than 3 would look like in interval notation right here. So definitely put them on a number line, helps a lot. Okay, so what about x is greater than or equal to -1? All right, so that's how we say that. So at -1, right, we need to figure out what numbers are we even talking about. Whoops, what numbers are we even talking about? X is greater than or equal to 1, -1. So here's -1 right here. And we want all the numbers greater than or equal to that number. So we're talking about these numbers, right? Talking about all of these numbers, okay? So we have an equal to sign, so we're going to include -1. And that's how our number line would look. Now, let's label left and right. Let's label left and right. Left and right. So where's it starting? Where's it going? It's starting at -1. And it's going to positive infinity. Okay, it's going to keep going on forever and ever. And I know I'm going to have a parenthesis on my infinity symbol because that's the rule. And I have an equal to sign in my problem, right? This is greater than or equal to. So I know I'm going to put a bracket on my -1, okay? And there we go. So we have a less than example, a greater than example. Let's look at this one. So we can read this as -2 is less than x is less than or equal to 4, and that would make no sense to you, right? That doesn't make a whole lot of sense. But we can break this into two pieces, and we can read it this way, and then we can read it this way. Okay, so this is what this one is saying. It's saying x is greater than 2. That's going this way. X is greater than -2. Okay. And at the same time, x is less than or equal to 4. Okay. So it's two things, right? X is less than this number and greater than this number. Okay. So let's look at what this looks like on the number line. Okay. So we have -2, which is right here, and we have 4, which is right here. X is greater than -2 means that we're looking at all of these numbers, right? And x is less than or equal to 4. So we're looking at these numbers. So what just happened was that we have a parentheses on -2, and we have a bracket on 4. Okay, that's because 2 didn't have an equal sign. 4 does have an equal sign. So we use brackets on 4, parentheses on -2. And so quite literally, the x is sandwiched in between these two numbers. Okay, so anytime you have something that looks like this, where x is in the middle, you need to think of a sandwich. Okay, you're going to sandwich those numbers. You're going to sandwich x in between those two numbers. So if we need to put this in interval notation and we're talking about where it's going, or where it started and where it's going, it started at -2 and it went to 4 because it's in between those two numbers. And we have a bracket and a parentheses. Okay, that's a parentheses. It kind of looks like a bracket. There we go. All right, so that is kind of all of the different ways that these can look in interval notation and on a number line. Once again, that's really going to help us if we label left and right. So let's look at how to solve an inequality. Okay, to solve an inequality, you will begin the same way you would in an equation. However, never change an inequality to an equation. All right. So, meaning that the whole subtract things from both sides, divide, simplify, all of that stuff will remain true. The only difference is you're not going to just have a straight equal sign. You're going to have a less than or equal to, a greater than or equal to. Okay. And there's one major difference between solving an inequality and solving an equation, and it's this rule right here, the highlighted rule. If you multiply or divide both sides by a negative number, you got to reverse the inequality sign. Okay, so if you had a greater than, you would change it to less than. If you had greater than or equal to, it'd be less than or equal to. And then same difference the other way. If it's less than, you make it greater than. That's the only thing that is different. Everything else is still the same. Okay, so this says solve the inequalities and write in interval notation. So we don't have to put these on the number line. If that helps you at all, then go ahead and do it, but you don't have to. All right, so we just need to solve this inequality. Okay, we're going to solve it the same way that we solve equations, except there's no equal sign. All right, so we're isolating x. All right, so we are going to subtract 1 from both sides because we're trying to get x by itself. So that created 0 here. And we get 2x. Let me make my pen a little bigger. 2x is less than 16. So then you're going to divide by 2 and get x is less than 8. Okay. Well, now we solved our inequality. All right, let's throw it on a number line really quick. All right, so here's 8. And x is less than 8. So it's all of these numbers, right? All of these numbers are less than 8. And I don't have a equal to sign on my inequality. So I'm going to put a parenthesis like that. All right. So to put that into a interval notation, right? We would have negative infinity, because that's where we're coming from, right? We're coming in from the left, right? We're always going to read this way. We're coming in from negative infinity, and we're getting really, really close to 8, but we're never going to get to it because we'll have a parentheses right there. And so x is less than 8 would look like this. Okay. What about this one? All right, same deal. We are going to isolate x. We're going to subtract 4 first and get negative 7x is less than or equal to 21. Then we're going to divide by negative 7. Okay. And remember that if you divide by a negative number, you have to flip the inequality sign. Okay, I just divided by a negative number, did I not? I divided by negative 7. And so I'm going to say x is not less than or equal to, but greater than or equal to negative 3. Okay, so I flipped my sign from less than or equal to greater than or equal to. Okay, so we need to put this in interval notation. We can keep throwing it on the number line, put it on negative 3. Okay, so from left to right, this is greater than, so it's going to go this way. And we would have that it's starting at negative 3 and going all the way to infinity. Okay, infinity gets the parentheses, but our negative 3 should get a bracket because it's greater than or equal to. Okay. Now, we have this one. Okay, this one's going to be one that I'm going to let you try. All right, and then when you get done with it, you should get that x is less than or equal to negative 9, and you should get infinity, negative infinity to negative 9, and you'll have a bracket on that. Okay, so you solve that and do it by yourself, and you should get that. Now let's look at this one. Okay, so this one would be the one where we have two things going on, right? We have 2x plus 3 is greater than or equal to negative 1, and at the same time, it's also less than 11. Okay, so when you're solving equations, like when you're solving inequalities like this, you're going to keep x in the middle. Okay, so you're never going to subtract 1 from all sides. Okay, because then you're going to miss this. Okay, you're always going to want to keep x in the middle. Isolate x in the middle. And so I've said this a lot, but what you do to one side, you have to do to the other. That is true, okay? But what you do to one side, what you do to the middle, you need to do to all three, okay? So I'm going to subtract 3 from the middle to create 0 to just have 2x, but I'm going to do it to all 3 sides, okay? And so I get negative 2 is less than or equal to 2x is less than 8. Okay, can move it over a little bit. And so I still have x in the middle. And so now I need to divide by 2. and I'm going to do it to all three sides. So I get -1 is less than or equal to x is less than 4. All right. So now I have solved my inequality. I have x in the middle by itself, and now I have two things going on. And remember, okay, these should be the easy ones to get the interval notation, because on a number line, this means that x is in between, literally in between -1 and 4. Okay. So your interval notation would say -1 and 4, and you would have a bracket on -1. Whoops, let me do. You would have a bracket on -1, and you would have a parentheses on 4. I'm trying to highlight that for you guys. All right, and then you're done. Okay, that's the answer. So your ones that are sandwiched, where you have two things going on, you're trying to keep that x in the middle. And then whatever you do to one side, you need to do just all three, right? And you're going to manipulate the middle. You're going to move things, zero out things from the middle. So that's why we subtracted 3 and we divided by 2, because we were doing things to the middle to get it to just x. And then your interval notation will just be the two numbers on either side of x. And then you need to work out your parentheses and brackets. All right, so we also have the absolute value of inequalities. Okay, so if x is an algebraic expression and c is a positive real number, then the solutions of the absolute value of x less than c are given by these. And then we have the absolute value of x is greater than c given by another thing. Okay, so you have the absolute value, you highlight the absolute value of x is less than c. Okay, this is called an and statement. Whoops. An and statement. Okay, the way that I keep this straight is I say less than. Okay, less than. That's how I kind of remember it. All right, less than. And you're going to turn these into a sandwich, just like the previous example that we worked in the last video. Okay, so this is going to create a sandwich. So you are going to have two things going on at the same time. All right, so you're going to have x is less than c, and at the same time it's greater than the opposite of c. Okay, so this is going to be, you're going to be using the positive and the negative. Okay, so you're going to sandwich those two things happening at once. All right, and then you're going to have the absolute value of x is greater than c. Okay, I keep this straight. Okay, this is an or statement. All right, and so this means that two separate things are going on. All right, if you have an or statement, and this is the way that I keep this straight, I say greater, right? Greater than, right? Greater, less than. An or statement means that x is greater than c or x is less than c, but not both. Okay, x is less than negative c, but not both. All right, and you're going to see when we put these on number lines that the and statements have everything in common and the or statements have absolutely nothing in common. Okay, so you're going to have a two-piece answer for your or statements because those don't have anything in common. And then you'll have one piece answer for your and statements. Okay, and I know that I did grade less than and greater than, but those can also be with your equal to's as well, right? So it holds true for your equal to's. All right, so let's work one and let's see what I mean. All right, we have the absolute value of 2x plus 3 is less than or equal to 9. So the first thing that we need to figure it out is this an and or an or statement? Okay, and this would be less than. So this is an and statement. Okay, and statements mean sandwich. So we're going to sandwich this in between two values and then solve it. Okay, and I don't think sandwich has an H right there. Sandwich, like that. All right, so we have 2x plus 3 is less than or equal to 9. All right, that is the same thing that's written right here, except without the absolute value bars. And then we're going to make the same sign. So we have less than or equal to, we're going to make that same sign on the other side. And then we're going to do the negative of whatever number we're given. Okay. Then we're going to solve this inequality. Okay. Which is a lot like some that we've already worked. All right. So we're going to keep x in the middle. So we're going to subtract 3 from all three sides and get negative 12 is less than or equal to 2x. It's less than or equal to 6. And then we're going to divide by 2. Remember that we're only going to manipulate the middle. So we're going to be left with negative 6 is less than or equal to x is less than or equal to 3. Okay. So we sandwiched it. Remember that the sandwiches are easier to put in interval notation because this means that x is in between the values of negative 6 and 3. Okay. So our interval notation is negative 6 comma 3. Both of them will have brackets on the ends. Make that bigger. So I get negative 6 comma 3. All right. So really, this is the very important part that you need to know, right? Is you need to be able to identify this as an and statement, say, all right, I need to sandwich this in between two values, and those two values are 9 and negative 9, and then solve. Okay. So this one, we're going to say the absolute value of 5x minus 6 is greater than 16. So this is an or statement. All right, so this means two pieces. All right, so this means that we're going to have two separate things going on. We're going to have 5x minus 6 is greater than 16, and 5x minus 6 is less than negative 16. Okay, so this part stayed the same. These parts changed. I flipped my sign and changed from positive to negative. Okay, so I'm saying that either one of these are true. It's either greater than 16 or it's less than negative 16. So I'm going to solve both. I'm going to get 5x is greater than 22, and I'm going to divide by 5. And so I get x is greater than 22 over 5. And then I'm going to solve the other one. So I'm going to add 6. And I get 5x is less than negative 10. I'm going to divide by 5. And get 5 is less than negative 2. Okay? So either x is greater than 22 over 5 or so 22 over 5, x is greater than that number. Greater than that number. So that means that it's going to be all of these numbers, right? At the same time, we have x is less than negative 2. So we're saying all of these numbers. Do you see that these have nothing in common? Nothing at all. Okay. So let's put these two things in interval notation. the first purple bit goes from negative infinity to negative 2. Both have parentheses. And then the blue part goes from 22 over 5 to positive 10. Both have parentheses. Okay, so you have these two pieces of your answer, and you are going to use the union sign in between them. Okay? So your answer is negative infinity to negative 2 union 22 over 5. So these have nothing in common when you put them on a number line, the or statements. If we put this and statement on a number line, we would have negative 6 and 3, and we would have all of this. Okay, these have everything in common, whereas these have nothing, right? The difference between and or statements, okay? Look at this one. I want you to take 30 seconds and look at it. And if you immediately said, oh, this is an and statement, I would say that you're not correct. This has no special rules. This is not an and statement or an or statement because there are no absolute value bars. This is not an absolute value equation, inequality at all. There's no bars. So this is just normal. You would just subtract 1 from both sides and get 4x is less than 8. Divide by 4 and get that x is less than 2. So you would say negative infinity to 2 and you would be done, okay? You only have and or statements. Okay, I'm going to write this down. I'm going to write it in red, okay? Very important. And or statements only apply have absolute value bars, then you're just going to solve the inequality just like you solve an equation and then put it in interval notation. Okay, it won't be any different, right? And so here's how these will look in multiple choice format. So I'm just doing this so that on your quizzes and things, you can notice them, okay? So the absolute value of x minus 6 is less than 4. So this would be an and statement. So you would have x minus 6 is less than 4, and then you would sandwich it in between negative 4. And you would simplify it, or you would solve it, and you would get 2 is less than x is less than 10, right? So then you would put it in interval notation and say that we're sandwiched in between these two. So whatever you get is what you would circle for your answer. So you would get D for this one, right? And so you could immediately say, okay, this is an and statement, so I'm going to sandwich it in between two values. And I know that and statements have a number, and I don't have any infinities anywhere in there. So there goes A and there goes C. And I know that I'm going to have parentheses on both because of this. This has brackets. There goes that one. So I'm only left with D. So on the multiple choice, you can really use process of elimination and think about these things for a second. Like the absolute value of 2x minus 1 is greater than or equal to 13. All right. Well, greater than says or. This is an or statement, so I know I'm going to have a union. No, 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 yes, and you're done. So you didn't even have to work that one. All right. So those will look like that in multiple choice format. Okay.